Hi everyone, Dr. Schmidt here with a Chapter 5 wrap-up, and this is a wrap-up about linear equations. Remember, a linear equation is what we focused on in Chapter 5. It looks like y equals mx plus b. The slope is also called a rate. We saw that happen. We also saw it called a rate of change, more commonly called a rate. But you will see in MyLab slope referred to as a rate of change. We used the letter m for slope, and the formula was y2 minus y1 divided by x2 minus x1. Another way you can think about that geometrically or graphically is rise over run, and let me show you why it makes sense to think about that. Because if you were to draw a graph of any of these lines, these linear graphs, let's say, I don't know, this one. Let's say this is a straight line that's not drawn perfectly. This is a linear equation, the graph of a linear equation. This right here is b, it's the y-intercept, which I'll remind you of down here in a moment. And if I just pick any 2 points, I don't know, I'll pick this one, so that would be x1, and this would be y1, and I'll pick another point further away so we have room to add notes to this. Please pause this. If I'm going too quickly, you need to take good notes on this. If we have these points on our linear graph, the rise is this. It's how much you go up. That's why it's y2 minus y1. It's the difference in the y values. So that's the rise. And the run is how much you go left to right. So that's why it's x2 minus x1. It's the difference in the x values. So that's one way you can visualize slope as rise over run. Another way you can visualize it would be if the graph was going downwards. That can happen too. Then this is your slope b, and once again, I'll just pick any 2 points. And for the sake of keeping this video short, I'm not going to label them x1 and x2 anymore. What I really want to show you is it's a little bit counterintuitive, but now the rise goes down. But we still call it a rise. It's just the rise is negative when the graph goes down because the slope will turn out to be negative. And the run, on the other hand, is not counterintuitive. The run is always viewed to be positive because we read our graphs from left to right. So you always view run to be positive because we read graphs left to right. Now, if your slope is ever 0, then the line will be horizontal. If your run is ever 0, if the run, which is the denominator, is 0, well, that's going to cause division by 0, so the slope won't even exist. Then the line will be a vertical line. As I mentioned earlier, the y-intercept is b. So that's this b or this b. It's just wherever the graph crosses the y-axis. Coordinates, you'll see this word in MyLab. Coordinates are always listed like this, parenthesis x comma y parenthesis. So like x1 comma y1. It's a point on the graph. In particular, it's this pink point. So they always correspond to a point on the graph, and you have to write it like that. A very special pair of coordinates would correspond to the y-intercept. The y-intercept coordinates are 0, comma, b. So now let me show you an example. Let's consider this graph. This graph is the water in a pool as it drains. On the vertical y-axis, we have the volume of the water, and on the horizontal axis, we have time. And first, we need to find the slope. So remember, that's just y2 minus y1 divided by x2 minus x1. And I can see some really easy points to read right here. This is the point 0, comma 8. That's our x1, comma y1. Those are coordinates. Oops, y1. And this point is 5, comma 0. Please notice you always list the x value first and the y value second. So that's our x2 comma y2. So we can use these numbers to get slope. 0 is our y2, 8 is our y1, 5 is our x2, 0 is our x1. Make sure you get those in the right order. Order matters, and I almost mixed it up. You get negative 8 over 5. Now, if MyLab asks for your answer in a fraction format, make sure you give your answer in a fraction format. If MyLab asks for it as a decimal, then you can write it as a decimal, but read the directions carefully. Now let's interpret the slope. Remember, we did this in one of your worksheets. The way you would interpret the slope is you would say the water, you could say water in the pool, or just water for short, decreases because the slope is negative, or changes. You're allowed to use the word changes as well. Decreases by whatever the slope is. Our slope is negative 1.6 thousand gallons. Watch out for that. It's not just 1.6. It's thousands of gallons per whatever our unit of x is, hour. That's one way you could write it. Oh, and you know what? Don't put the negative there. The word decreases encompasses the negative. I was redundant, and you can't be redundant like that. Now, I was about to tell you what you can do with that 1.6 thousand. You could say 1.6 thousand. You could take that and turn it actually into a number. That's 1.6 times 1,000 is 1600. So you would have 1,600 gallons. That would be another way you could say this. Just pick your favorite. What is the v-intercept? The v-intercept is like our y-intercept, except they're calling this the v-axis up here. See what I just did there? We're calling that the v-axis now because it's not just some variable y. It means something in real life. It stands for volume. Nonetheless, it's this value. That's the v-intercept because it's where you cross the vertical axis. So 8. If they asked you to interpret it, which they didn't, but if you had to interpret it, you would need to use 8,000. If they just asked for the v-intercept, that's just a mathematical thing. It's the number 8. But if you had to interpret it, then you need to make sure that you use the real life values. That 8 is in thousands of gallons. How much water is in the pool after 3 hours? Well, we're going to have to do some side work before we can answer that question. You need the equation of the line to answer that question. So we have the v-intercept right there. We got our slope right here. So the equation of the line, remember that's y equals mx plus b, will be y equals negative 1.6x plus 8. So we have our equation. Now we can come over here back to the problem, and we can use it. How much water is in the pool after 3 hours? Well, that's an x. And actually, why don't we use a t and a v instead of y's and x's, just to make this more realistic? Let's make that a v and a t. That'll be good practice for you. So that means t is equal to 3. So we just plug it in. So v equals negative 1.6 times 3 plus 8. You can put that into a calculator. Just make sure you multiply or use parentheses, either way. And if you put that into a calculator, you're going to get 3.2. But that's in thousands of gallons, just like our y-intercept was. So if you want, you could write it like that, or you could write that as 3.2 times 1,000, which will give you 3,200 gallons. How long will it take until 2,000 gallons remain? Let me make that a little bit easier to see. Well, that's not a time anymore. That means V is 2,000 gallons. But the thousands is already accounted for, remember. The thousands is already accounted for, so we just use the 2. V equals 2. And we take that, put it into our equation. And now we have 2 equals negative 1.6. We don't know what t is. That's what we're trying to find. We have to solve this equation. So if you subtract 8 from both sides, you'll get negative 6 over there. These cancel. If you divide negative 1.6 from both sides, these cancel, and you get 3.75. That's t. Remember, t is in hours, so 3.75 hours. That's how long it will take until 2,000 gallons remain. How long until the pool is empty? Well, empty would mean V is 0, right? Because there are 0 gallons left in the pool. So we're going to do the same thing we just did in part E. We're going to take 0 equal to our equation, because we're putting 0 in for V, and solve. So we'll subtract 8 from both sides, just like we did before. And we'll divide the negative 1.6 from both sides like we did before, so that we can solve for t. And if you do that, you get 5. And remember that t is in hours.